So, Bazel, do we really need another build? Should you need this build tool? Okay, so my first question is, who has used Bazel? Oh, quite a lot of you. And who loves Bazel? Raise your hands. Yeah, a little bit less hands, but I'm surprised that like 4, 5, 6 people. I'm really surprised. I would expect close to 0, but yeah. Okay, so yeah, about me quickly. I'm Jarek Ratajski, work at the digital asset company. We created a Dumble smart contract language, so it's Haskell-like contract language, and we are working on Canton Network, which is basically blockchain for financial institutions with a privacy and all that stuff. But that's not what I'm going to talk today. Maybe interesting part is like, even though right now I write Scala and occasionally Haskell, I spent almost 20 years of my career with Java enterprise system. Also doing other stuff, including Scala and Kotlin, but yeah, mostly Java. That probably sometimes explains a lot. But OK, so I will make it very quickly. Should you build your next project with Bazel? What do you think is the answer? Yeah, yeah. That's my, so it's like, this is my message. OK, I would say probably, because it depends. Always, this is depends. Unlikely, but maybe, and this talk is about this maybe. So actually, Bazel is interesting. It's if you spend, who actually loves his build tool? Like, who loves SBT? Not that many hands, but some. Who loves Maven, the best one? yeah, Maven lovers. And Gradle? Okay, and I know what tool, but that will be in the next talk. About one that actually people maybe love, but okay. Okay. So, the thing is that you may not choose Bazel, but you know what can happen. Bazel may choose you. That's what usually happens. And that's how I learned about Bazel. So Bazel was started in Google. Initially it was called Blaze. Yeah. And then they made it publicly available and changed the name to Bazel. So Polish people sometimes call it Bazel, which has a meaning in Polish. So it's colloquial name for, let's say, it has different meaning, some little bit not politically correct, but one colloquial meaning is disorder, chaos. Like the thing happens that when you don't clean, which is important. So many companies use it. So when I talked with people at this conference already, I realized like many of you, and I actually asked, are using Bazel now? Actually, more than I expected. So surely big companies use that. When you go to the page of Bazel, you will find many interesting names there. And then there is a list of open source projects that are using Bazel. For instance, our project is there, Dumble, but some others. I was quite surprised about Selenium, for instance. But yeah, you looked at the sources, they have Bazel there. But then I looked on one of those projects, and I was quite surprised. Kubernetes used Bazel. So I looked at the sources, and guess what? I found absolutely no traces of Bazel. So that sounds like a lie. So I tried to dig a little bit deeper, and I found out that there are actually issues and pull requests about Bazel in Kubernetes. And the quite recent one is this. This is actually an issue. Inquire about the Bazel build tool support removal. So that basically a user questions, why did you remove Bazel? And then comes this answer. So after some links, like basically Kubernetes has 2 build systems for Go and Bazel. And yeah, and they found out that slowly as the Go modules cache become better, maintaining 2 build systems, so Bazel, which was initially there to just be faster alternative, maintaining both of them became tedious, and basically people were complaining about Bazel, that how do I do this thing that should be moderately simple to do if it wasn't wrapped in Bazel? Yeah, that's like basically, so people were complaining. And I can really relate to this. Like that's, if you work with Bazel, complaining is a thing that you get used to. Okay, so yeah, so they decided to just drop Bazel and forget about it. Yeah, a little bit sad story, but that happens. So anyhow, many companies use it, and now let's get to this Bazel. So one maybe important thing, I am not any Bazel expert, I just use it. This talk is from the regular user perspective, the user that tried to learn a little bit to just suffer a little bit less. And you know this kind of sayings, advertisements that you have two things and you choose both of them, like Scala, convenient and safe. Bazel, fast and correct, choose two. Yeah, that's great. You always should think what was not on the list of choices. Like, simple, user-friendly, all that stuff. Yeah, it's like, actually great sentence yesterday was exactly in this hall. Martin Onderski said something like this, I noted. That was about SBT and about growing complexity of SBT. He said, if you do not get this build tool in 30 minutes, it means it's too complicated. And that was about SBT. And I can tell you, SBT is not that complex when you look at the Bazel. So, yeah, and I would say in terms of case of Bazel, I don't know if 30 hours is enough to write build fluently. Depends what you do. But I will show you the principles of Bazel are simple, but the problems that you get are not. Okay, so that's when I first started to use Bazel. Okay, I will ask. So building was really fast and fun. Who had really initial good experience with Bazel? That everything built fast. Okay, I would say that was my confidence in this tool really grew quickly. I was like, after few hours of just using them, modifying the code, running tests, I really liked this tool because it was fast, it was fun, and I see that I don't have to do, for instance, this. I told you what is Bazel in Poland. Things that happen when you never clean, so in Bazel you never clean. Actually, however, nothing wrong happens. This is the difference. So maybe that's why it's not actually called Bazel, but Bazel. But anyhow, you don't clean because you don't have to. Basically, the chances that your build are broken and you have to clean are really small. So, and it's extremely parallel. You see it. You run it, and instantly you see like 10 jobs running at the same time. It's really cool to see that. And it just works. So how Bazel works, now we get to a little bit of data. This will not be, I don't want to teach you about Bazel, but I just want to show you the stuff so that the next part is, we can relate what I'm talking about. So it all starts with this workspace. So this is a very simple project in Bazel, and we have a folder that has a workspace file, and then we have some build files, and we have, for instance, Scala files there. So the central part is this workspace, and it looks like this for Scala. And if you try to read it, you see that there are like two types of invocations here. Like loading something from maybe from built-in repository, and then, for instance, in the first line, I load something called HTTP archive. Cool. From this address. It's like Bazel internal tooling. Then I load using this HTTP archive. It means now I have, it's like import. I have HTTP archive. I can load something called Bazel skylib. No, what is Bazel skylib? No one knows, but it must be there. Okay. Then I load something that I can actually relate to, and it's interesting is Bazel rules Scala. Oh, great. And with a version and SAH, great, it's safe. Then, yeah, I load Scala config from that. Cool, because I defined the symbol IO Bazel rules Scala, then I can load Scala config. I can config Scala to use this very not outdated Scala version. And you see, but then I load, for instance, proto dependencies. You know what? My project doesn't have anything related to protobus in this particular case, but still I have to load. If I remove those lines, this will fall apart. Don't ask me why. No one knows. Okay, there is explanation, but yeah, I don't want to get into those details. But so what you've seen in this picture was a language which is basically Python simplified. It's called Starlark. But let's say it's just Python, but a subset of Python that it's not Turing complete, which is great. You don't want your build to get into infinite loop. Yeah, that's awesome. Actually, any language is simple, no problems understanding it. Yeah, and how the workspace works is basically it protects you from your project from external influence. From on one perspective, on the other hand, it actually connects you to the external world. In a workspace, you are supposed, and you will see that, to declare everything from the outside of your project that your project depends on. For instance, here, I depend on Scala. For some reason, I depend on Proto and stuff like that, but let's say I depend on Scala, and the rules are just there. And nothing else should get into my project. Okay. So it doesn't matter what Java version I have, I don't know, GC compiler, what Scala versions I have, SBT version I have on my PC. That doesn't matter because all the dependencies are in a workspace, which is important. And now we have build files, so build, define packages. So we see there are two like module A and module B. Build, they can be named build or build Bazel. It actually changes between versions, but that doesn't matter. And the build files are actually simpler and quite easy to understand. For instance, this is a build file, which initially, again, I use this load invocation. I defined three symbols, let's say, in my namespace, Scala binary, library, and test. And you can guess what it is. Library creates a jar from these sources. Binary creates a jar and depends on a lib. So, and tests, yeah, they define tests. It's simple like that. So basically, workspace, packages, and targets in packages. Yeah. Now, very important part of the Bazel is a sandbox. You will see that it does some sandboxing. What is this sandboxing? It's not really that perfect isolation of your build. So when Bazel builds something, it loads everything in a special folder, and from this folder, everything is invoked. And technically, and in theory, nothing else is referred. In practice, this is not perfect isolation, so you can easily, for instance, write such an evil macro, like I can access a user file on a local disk, and by default, nothing will really stop me from that. But you know, if you do such a stupid thing, you will get actually with build that it's not repeatable because it actually contains some hard linked, let's say, file. Like here is the string El Chupacabra that I had in this file. And you get that actually in a bytecode, yeah. So you do stupid things, you know, you win stupid prizes. So it's not that it's like totally foolproof. It's like there are some levels of this isolation and there are some additional things here that play a role. But by default, if you run it on your computer, because it must be relatively fast, so it doesn't really do any totally safe container. You have a read-only access to actually all the files on your PC. But okay. But normally, nothing wrong should happen unless you are actually evil, which I hope none of you are. Okay. So now important part about this. This is, Bazel wasn't built for Scala. And actually, it wasn't built for any particular language, although the two are quite native to it. So C++ and Java are kind of built-in languages. All the rest is you get via external rule sets or extensions. That is also changing because some of them are now in a Google repository, let's say Bazel repository with extensions. Some are really in totally external repositories. But basically, any language you can imagine, either any popular language, either there is already a rule set for that, or you can relatively easily write your own with this Starlark. Okay, a short demo. Okay, so now come. Maybe I have to switch display a little bit so that I. Okay. Okay, so we'll look at this project. Maybe. So there is actually multi-language project. So we have this is a module called CPP. It's just and you can imagine it contains C++ code. Okay, I will try to make it reasonably visible. So yeah, hello world from C++. Then you have this Go module, and it contains hello world with Google. Then you have Rust, very simple hello world. And by the name, those names, Go, CPP, that could be any name. It's just the name of exactly this package. So I could name it, I don't know, I hate Rust or whatever. I don't actually. But you know, it doesn't matter. It's just my name. And then I have Scala, let's say everything that we love. And in this Scala, let's look at, okay, maybe look at this build. Here, yeah, we have define a Go binary, and then in Go binary we have sources and visibility public. Then in Scala package, I have such targets, and in those targets, for instance, Scala binary, I declare that I use binaries actually from those three languages. So this is not a library dependency as if it was like a foreign function interface. It's actually binary. I wanted to make it very simple and to demonstrate. So I depend on binary, and also I depend on jar, which is produced here, so other target a library in Scala. And Scala code is relatively simple. I just call these three other languages to print output, and then I print finally hello world from Scala. So let's just use it. Okay. I want to, sorry, moment. Okay, for some reason I don't have my console, but you know what? I will use other console. Okay. Okay, that will make it bigger. And okay, and this was, I think, multi. Okay. Okay, so this is this project. And now I'll just write Bazel build. And I could write 3 dots, but by default you will actually write. So build me everything. And it will take a little bit of time. Oh. Sorry, what?
The L and the E are flipped around.
Oh, Bazel. Oh, yeah. So oh, come on. So you see that instantly tons of things is happening. You see 172 tasks are running. So it doesn't look simple. Like tons of parallel things are happening. Yeah, and because I cleaned it, actually, just to demonstrate, it seems kind of slow right now because it loads all this stuff, and now you see it runs of this Linux sandbox locally, and slowly we are getting there. You know, typically 169 of 172, and yeah, it's built. It didn't run because in order to run it, it's relatively simple. I start with there was a Scala subfolder, and in this subfolder I had a main target, so I have to run it. I could build it, doesn't make sense now, but I can run it, and bam, you see hello world from C++, hello world from Rust, hello world from ugly, you know, and from Scala. So maybe we want to change this ugly stuff. Yeah, just accident, so we'll change this Go. It's not really that ugly. Call it Golang, and we'll see what happens. I'll run it again, and you see, it was relatively fast right now. And maybe there is no exclamation after Scala, so let's change it. Ta-da. Let's just do it. Now Scala takes a little bit more time, but you see, it was relatively quickly. And that's a typical experience with Bazel, that you have huge projects with tons of modules, tons of dependencies, multiple languages. But when you start to run tests and stuff like that, you see that it builds very quickly. So you can love it, actually. So, but then, and the command line that you just demonstrated is fairly helpful. I like it. It's very decent command line with tons of helps, like querying. Nothing that we don't have right now in SBT with enough plugins, but it's there and it's really well done. So I like it, and you might like it as well. So you've seen that it's extremely parallel, and native to Bazel is to have a project with tons of small packages. And then it can use caching because it isolates. It means it's safe to run all those stuff use cache, run parallel, even run on remote machines in a build cluster. We have that right now that in Gradle, I think in SBT, but I forgot if I actually even used that. Surely I used that with Gradle. We have all that stuff in on any new decent build tools, but those are things that become built later. For Bazel, it's kind of native. So this is what makes it, let's say, relatively safe in such environment. Okay, so important part, you don't have to follow strict rules as in basically by default in SBT or Maven that you have this SRC main Scala or something. You can be completely crazy. Like here, each Scala file has a build. So it defines different package. So obviously, it's an exaggeration. Actually, here would be each Scala package has a build. And that's the way to split your whole code into many small modules so that dependencies are more strictly followed. And you have, in case you rebuild something, it's a very small change. You don't rebuild everything. That's basically there is no magic. It's not that Bazel magically makes everything fast. It makes it fast when you split your code correctly. Okay. And then it can use really parallelism. Okay. So yeah, that was one also great thing about Bazel. It's quite straightforward. There are some rules. So if you depend on some module, it's really easy. / is a root of your workspace, and then must be a package SRC, must be a package main. I mean, if it's written here, it means in my workspace exists package folder that is SRC main Scala. As I said, can be whatever. And then there is surely a folder example and surely a folder A, which has target libs. And that's how I depend on internal module, actually target, simply. So the problem comes with external dependencies. So let's suppose, if I want to, for instance, build Tapir project because something on top of Tapir is great, you know it, so you define these dependencies and in a workspace file. And as I said, workspace is your connection to external world. So generally that's enough. You define that, I have external Maven repository and I take these 3 dependencies, okay, the 4 actually, and with all transitive also dependencies. But this is in a workspace file. By default, when you do a package and you do a build, and now there is my code, I have to repeat that now a little bit differently because those external dependencies were loaded by a workspace, and now I repeat them because this particular build depends on those, and then by default, I have to list all transitive dependencies. I don't want to get into details of that. Let's say it's a safe default, but quite tedious. So you don't have to do that. There are modes when, like +1, so you don't have to list here dependencies that are direct dependencies of those 4 above. And there is even full transitivity. But let's say in a serious projects, you quite often want to be very explicit about your dependencies to avoid surprises when a version changes and some transitive dependency is gone and you don't know even why and you have errors in builds, etc. So it's a trade-off. But if you have that as well, you can have this kind of strictness with SBT and plugins. So there is additional alternative approach. There is a tool called build depths for basically JVM, which brings your dependencies into as dependencies in a workspace. So we see this tool creates this third-party folder, but I don't want to go into details. Simply, there are tools that help you manage those external dependencies, and we use that tools. And basically, every bigger project in Bazel uses some kind of tooling, especially for external dependencies. Okay, so and now so this is external dependencies are quite tedious, but then comes a bigger problem. What happens when you, for instance, see that? This is not that fresh version, but this is something that you get when you just take an example from Scala rule set that we defined in the works. So I wanted to change it to the more modern Scala, like 364. So, I got angry at that. I changed it, and guess what happened? Key 3.6 not found. What is that? And then you get into and find out that the Scala rule set is actually quite now outdated, like last version was published some time ago, and it just doesn't have a modern, doesn't really have definitions for new modern Scala versions with a new dependency. So then I spent time what can I do? And really, 5 hours later, I found out that I forked the Bazel rules Scala because there was a guy, Wojtek Mazur, actually, yesterday I was talking, who actually merged this and pushed a pull request to the Bazel rules Scala, but unfortunately, it's still not published officially. So basically, everything is there, but you have to do your own release. Okay, I can live with that. The problem is that it still didn't work because some magic incantation, I don't know, this Skylib or something in the workspace have changed. And basically, I made it working by just taking a completely fresh workspace with new magic incantations and then changing what I needed. So, and this is, when you just rewrite a lot of code that you don't really follow, it's a bad sign. Yeah. And it is something that we suffer in the company. So for instance, the thing, we just wanted to, for instance, update Scala, and we see, we have right now quite outdated Bazel. So we see in order to use new Scala, we need to update Bazel as well, because then we will be able to use new rule set. Okay, so we update Bazel. And then it seems that we also have TypeScript. But TypeScript rule set we are using is outdated, doesn't work with a new Bazel. So we have to update TypeScript rule set. Okay, we find out what is the new TypeScript rule set. Okay, we enter. And this TypeScript rule set actually requires a new compiler, a new TypeScript compiler. It just doesn't work with old. Okay, no problem. But this new TypeScript compiler doesn't actually compile our sources anymore. So by just wanting to change, upgrade Scala, we ended with rewriting our very outdated TypeScript code in one of the modules. Great. And that is unfortunately quite a typical experience. This is called like dependency hell. You push a small stone, a string, and everything falls apart. Not in an external dependencies, but basically Bazel, because Bazel is very evolving. Like it has quite often new versions, and those versions are also not really compatible. And then you have rule sets for languages that also doesn't really catch with Bazel versions. So sometimes finding, this very precise versions that would actually work with your build, it's a tricky thing. Okay, so you have Bazel RC, so basically the file that you can put some switches that enable some options. So it is not totally, there are some things you can switch on, switch off to maintain backward compatibility, and you can keep that your Bazel version is, for instance, forever 7.6 or something, or 5. So that's not, you will not get random updates of Bazel, but still it's a little bit of pain. So when it comes to IDE support, it's mediocre. So there is a plugin for it that I am using. Occasionally you have to, for instance, change to the older version of plugin because newer will not work. There are crazy things happening, but it generally works. There is plugin for VS Code, generally works. Okay, but when you use with it Scala, you won't have navigation to all the symbols. Some will work, some will not. Nobody knows why. There is a Bazel BSP. I've never personally tried, but seems that it works. And basically, the thing is that whenever you use Bazel, you almost certainly will end up with tons of additional tooling, like Bazelix for Bazel management, Gradle for creating builds, Bazel BSP, Bazel Depths for this management if you are on JVM, and sometimes scripts for dependencies for doing releases. So basically, it's like not great, because then you move between two Bazel projects, between different companies, and you have to relearn this tooling again, because it's completely different sometimes. So I'm going to sum it up. So it's agnostic, but basically core team is working on Java and C++. But it's very unlikely that a Java developer will choose Bazel, because they have Maven, and they are happy with that. Very unlikely C++ developer will choose Bazel, because C++ people will see that there is a Java code in Bazel and will never use it because of that. And OK, so we have some pains, but I can tell you one thing. If your project is large enough, you have multiple languages, which are not JVM languages. So Scala, Java, and Kotlin is not enough. You need to have C++, Rust, Go, or something. And you have multiple modules, I don't know, 40, 50. And you have long build times. And particularly, you are having monorepo. That's what Bazel was built for. And maybe in that rare case, actually Bazel is the best tool you can use. I don't know. You can try it. You should know about it. OK, and that's all. Thank you.